Okay, so we're busy in the AP grade 12 with the functions of functions, and we've discussed now last time combining and composition. So in this document I've loaded up for you, there's some more stuff here about functions that you can just go over. It will be very good to just read through this document. You know, the vertical line test, showing that this is a function, that is not a function, things like that. And then of course domain and range that we're going to look at tonight, and then the sort of the general functions that we find, like polynomials, hyperbolas, absolute values, surds. Okay, so yeah, and to see what is going on there. Right, but I'm going to use the latter part here to talk about the domain and the range. Also about your input values and your output values, which is the domain and the range and so on. And then all of you are going to do inverses also, and so it's just good to maybe page through this document, just as I say, read through it. If you then have questions, then come on Fridays, come ask your questions and so on. Also, what is even and odd functions? I'll come back to this, because in AP they don't ask it so often, but they do want you to know about it, but they don't really ask it as a question. But I think it's just good if you know it, but I'll come back to that. So that's not on tonight's planning. Alright, I'm just paging through here that you can just see what is all in here. So combining functions we did last time, and we said when you're combining functions you are actually talking about adding them, subtracting them, multiplying them, and divide them. And when you divide them, remember that the bottom one, the denominator, can then not be 0. We may not divide by 0, as you all know, so be very careful. That's actually the only one that can give a problem. Okay, so that's why that one is the most popular to ask. Okay, and there's an interesting exercise and so on. And then here's an example, but we did examples last time. I think we can just go here now and just look at what is going on here. So here it says if f is the square root of 4 minus x and g is the square root of 3 plus x, find f plus g, f minus g, f times g, f over g, and give their domains. Okay, so we need to talk about the domain. So I'm going to first explain, and then I will go to Jamboard again and do ones with you. Okay, so what I always do when they give me functions like that, I will start from the start finding the domain of each of them, because I know they're going to ask me the domain. So I will look at what can the domain be here and what can the domain be here. Now remember, for domain in a surd, the inside cannot be negative. So in other words, 4 minus x should be greater and equal to 0. Okay, so maybe I'm going to put this on Jamboard quickly, and then we can just discuss it there. Okay, so we're busy with this example, and as I said, when I see a function like, you know, they give me this f of x, which is 4 minus, square root 4 minus x, then I know that the inside cannot be negative. So I know that the inside there, 4 minus x, this is now for f, that 4 minus x should be greater and equal to 0. Now remember, you're going to multiply by a negative, so therefore x will be less than equal to 4. Okay, that's what they got here. X will be less than equal to 4. Okay, and the same for g. The same for g, the inside there must be greater and equal to 0. So x plus 3 must be greater than equal to 0, the inside. So x must be greater than or equal to minus 3. Okay, so there's the domain of f and there's the domain of g. Now, when you do combining, it's actually very easy. When you do combining, remember, then you add. You don't have to simplify there. You could just show that you add this. When you do the subtraction, you show the subtraction. When you do the multiplication, you can make 1/3. Because remember, in mathematics, if we have a third times a third, you can have a third of the multiplication. We talked about that last time too. And also about the division. So it's f over g, but that will be the square root of f over g. It's the same thing. I don't think if they want it in this way, I think they will tell you in this form, but otherwise you can stop there. I think the multiplication is better to just give it like 1/3. Alright, now when you do the domain and range for combining, remember we're not busy now with composition, we're busy with the combining. When you do for combining, meaning adding, subtracting, multiplication, division, your domain will always be the combination of these two. So you must make one domain out of f and g. That will be true for the first 1, 2, 3 of them. In other words, it will be true for adding, it will be true for subtraction, and it will be true for multiplication. But for the division, you must make sure that you don't divide by 0. So therefore, if you look at this now, if we look at a number line now, I mean we've got 4 there, and it's telling us that it must be less than or equal to 4. So basically less than or equal to 4. And it's telling us we've got minus 3. And the minus 3, and it's greater than or equal to minus 3. So clearly the overlap is between the two. So that should be the domain, and that's why they got the domain as between minus 3 and 4. Alright, but now for the division, x cannot be minus 3. So for the first 3 there, this will be your domain. But when you get to the division, g of negative 3 gives you 0, and you may not have 0 underneath. So we're going to just exclude the minus 3 here. So in other words, for the last one, which is then f over g, the domain will be minus 3 up to 4, but the minus 3 will not be included. That's the only difference. Okay, so that's how we find the domain and the range for combining functions. Okay, so as you can see here, for the first 3, meaning adding, subtraction and multiplication, that will be the domain then. But for division, we may not divide by minus 3, so we should exclude the minus 3 from our domain. So for the division, this will be the domain, and for adding, subtraction or subtracting and multiplication, that one will be the domain. Okay, so it's not really so difficult, I would say. Alright, let us go to f of f. These functions now, the circle ones that we did last time. So that is composition of functions, okay? So, and we said that f circle g means you must put g into f. And g circle f means you must put f into g. So here's our f and here's our g. Okay, so I think again, it is good that you find the domain and the range of each of them before you start. Okay. Okay, in this example 2 now, we're going to look at, as I said, composition of functions. So, where we put one function into the other function. Now, before you start, again, I would recommend, I think it's just a recommendation that just do your the domains first. So here we can see it's a hyperbola. We've done hyperbolas, and we know that the bottom cannot be 0. So in other words, x squared minus 1 cannot be 0. Okay, so that's going to give us that x cannot be plus or minus 1. Okay, so the domain is going to be everything except 1 and minus 1. Okay. Alright, so that is the domain for f. If you just write here f. Okay, so remember now f cannot be 1 or minus 1. Okay, anything else but not plus or minus 1. And for g, it's a surd again. And for the surd, the inside must be greater and equal to 0. Okay, so when we combine, I just wanted to say, remember now that there's your minus 1, there's your 1, cannot be that, cannot be that, can be anything else. But here we have 0 and we have greater and equal to 0. So basically, well, this part is now out here. We're not going to, because we must find the combination of the two. So in other words, x can now be greater and equal to 0, but not 1. Okay, so x can be greater than equal to 0, but not 1. But listen now, there's a catch now in the composition of functions. And you must understand this now. When you find the domain of the composition, don't confuse it now with combining, okay? When you try to find the composition, the domain of the composition, okay, let me explain it this way. If you want to throw a paper into the dustbin, okay, listen again. If you want to throw rubbish or something into the dustbin, that paper must first exist before you can throw it into the dustbin. Okay, so that's very important. So when you do composition, say now we do G circle F. So in other words, let's look at this one first. G circle F. Okay, so that means we put F into G. So when we put F into G, we start with F first. Okay, so because, as I say, if you want to throw a paper into the dustbin, that paper must exist first before you can put it into the dustbin. Okay, so you look now, G circle F means you must put F into G. That means F is now like the paper that must exist, and then I'm going to put it into G, which is like the dustbin. So F must first exist. So you're just going to look at the domain of F then. Okay, so our first step will be to look now at the domain of F, which is this. Anything except plus or minus 1. Then you do your composition. So now you put your F into G. Okay, this is done here. This is done over here. Okay, let me just highlight it here. There we have put F into G. Okay, so I can also do it like this, and then you can see it and it'll go away. Alright, okay, so that is basically the result. Okay, after we've put F into G, that is the composition of the function that we did last week. So that will be the final result. Now you must find the domain of this function. Okay, so when you do composition of functions, you first find the function that you're going to substitute in. You find that domain. Then you do the composition, and then you find the domain of the final result, and then you combine those two. Okay, that's the difference. Alright, so now we need to find the domain of 1 over x squared minus 1. Okay, now again there's a surd. That means that the inside, okay, I just want to change the pen here. I don't want that to be the pen. Okay, so let's start again. So again, x squared minus 1 must be greater and equal to 0. Be very careful. This is normal grade 11 work, inequalities, which you must factorize. Those of you that has done those paper ones, question ones with me, will know how many times this was asked in the grade 12 papers. And then we have minus 1 here and we have 1 here. But remember now, x cannot be plus and minus 1. That we already know. So we're not going to include them here, because we already know that x cannot be plus and minus 1. So we have positive, negative, positive. Okay. So therefore, x must be greater than equal to 1. X must be greater, not equal to, greater than 1, because we need to find the positive ones. Greater than 0 is positive. Or x must be less than minus 1. So that is what the composition gives us. Now we can say this is 1 and this is 2. Now we just check that 1 and 2, what is the overlap there? But you can see that there's nothing is going to change. Now x cannot be plus or minus 1. We already did that. So that's no problem. So our final result will be x is greater than 1 or less than negative 1, like they did it here. Okay, so negative infinity to negative 1, or from 1 to infinity. That will be the domain of the composition. Right. Okay, if we look at the next example, it tells us that f is the square root of 4 minus x squared, and g is the square root of 3 minus x, and we must find f circle g, meaning we're going to put g into f. So we will first look at the domain of g. Now the domain of g will be 3 minus x must be greater than equal to 0, and that's going to give us less than 3. So x must be less and equal to 3. So that is the domain of g. Now after that we put our g into f. So we put the g into f. There it is. There's the final result. Now we find the domain of the final result. In other words, this is now the composition. This is now f circle g. So now we find the domain of this. Now the domain of this one is the inside, which is 1 plus x greater and equal to 0. That will give us x greater and equal to negative 1. And now we combine that greater and equal to negative 1 with our less than equal to 3. There it is, those two. And we will see that is going to be the overlap. So that is going to be the domain. Okay, I hope you understand this. Okay, so final thing for tonight, let us look at the decomposition of functions. So in other words, if I have the composition, how can I decompose them into the two original functions? Now, this doesn't have a unique answer always. You can have more than one way of getting to the answer here. So it's not always just a unique answer. So say now we have f as the composition of two functions. So this is already a composition of two functions. Okay. So what two functions can I come up with that will, if I combine them, will give me this? Okay. So then maybe I can have a g that is x squared plus 1, and then I can have h, which is the square root of x. So if I put this now in there, I will have that. So in other words, if I do H circle G, meaning I put G into H, and this is my G and this is my H, I will find that. Because if I put my G, which is the x squared plus 1, into the x here, it will give me that. I will then have the square root of x squared plus 1, which is G. Okay, so it's not so difficult to decompose. Let's look at another example. Let's look at this one. So write the function f to be 3x plus 5 to the 5 as the composition of two functions. Okay, so I can have a x to the 5. There it is. And then I must just have a 3x plus 5, you see. So I can have a 3x plus 5 and an x to the 5. Now if I put this 3x plus 5 there, I will have 3x plus 5 to the 5. So I can make this my G and this my H, and then this will be the composition. Just please remember to put off your mics, Deacon. Okay, so that is how we decompose functions. Alright, so let us I just want us to try once on Jamboard again now. So I'm gonna put this now into Jamboard. Okay guys, so yeah, on Jamboard page 4 we have now two examples that I want you to try and find for me f and g. Be very careful now. Remember now that your h is g, circle f. That means you must put f into g. Okay, I'm going to give you a link in Discord and I want you to write for me your answers there on that for 5 marks. Right, okay. So the people that watch the recording, you must also try to do that. Okay, so I'm just going to stop the recording here now and we will come back for the answers later. Okay, so the important thing here, then it's actually very easy, is to understand what is the inside function. So if it's g circle f, alright, then it means that we must put f into g. So f will then be the inside function. F will then be the inside function. Okay, and g will then the power function, the outside function. Okay, and most of you got that right nicely. The same here, f will be the inside function. So it's really not difficult. It sounds difficult, but it's not. And you can have more than one answer here, but okay, I'm going to do that, and then I'm going to say g is x to the 5. But you can actually have maybe a 1 over x to the 5 or something, and then your f just be 3x minus 5. So you can have more than one answer. There's not always just one answer here. As long as you understand that the right hand side one must be the inside function. So if it's g circle f, then f is the inside function. Okay, so I think it's also good that you look at that other books of other notes that's on there, where it's also that you can also look at the domain range there. But this is what it's all about tonight. It's about combining, composition, and finding the domain in each case.